This lesson we will be learning about estimating roots. We are going to estimate the square root of 19. What would that be to the nearest tenth? So first you really want your list of perfect squares out so that you can first narrow it down to which two integers it would be in between. So 19 comes right here between 16 and 25. So the beginning of our number line would be square root 16. The end would be square root 25. The square root of 16 is 4. The square root of 25 is 5. So I know that the square root of 19 has to come between 4 and 5. So I'm just going to label my number line, and I'm going to put 4.50 in the middle, 4.5 right in the middle. So we're now going to see where square root 19 comes in. We need to list out all of our square roots that come between. So after 16, it would be 17, 18, 19, 20, 21, 22, 23, and 24. So we need to count how many square roots are between 16 and 25. So from 16 to 17 would be 1, 17 to 18 would be 2, 3, 4, 5, 6, 7, 8, and 9. So there are 9, the distance of between 16 and 25 would be 9. So that goes on the bottom of our fraction because that's our total number. Now we need to count over how many there until we get to 19. So there's 1, 2, 3, 4. So 19 is four of the way over out of 9. So we would divide 4 divided by 9 and get 0.4444 repeating. So what we would estimate that the square root of 19 would be, well, first of all, it would start with 4 because it's between 4 and 5 on the number line. And it would be 4.4 to the nearest tenth. Now we can always check our work because this is an estimate. So we need to check our work. So we're going to take 4.4 squared so we can check our work. 4.4 squared is 19.36. So that gets us pretty close to 19. We're going to check the 2 around it as well. So 4.3 squared would be 18.49. And 4.5 squared is 20.25. Well, we can automatically get rid of 20.25 because that is not very close to 19. And so it's just left between these two. Well, 18.49 is 51/100ths away from 19, but 19.36 is only 36/100ths away from 19. So our original estimate was correct, 4.4. We're going to do the same thing, except we are going to do it with a cube root. So cube root of 14, first we're going to look at our perfect cubes and decide where it falls. Well, it comes right here between the 8 and the 7, the 8 and the 27. So the cube root of 8 is here. The cube root of 27 is here. The cube root of 8 is 2. The cube root of 27 is 3. So we know that the cube root of 14 is going to fall somewhere between 2 and 3. So I know it's going to be 2 decimal point something. So we're going to figure that out to the nearest tenth. So when I list all my numbers out, 9, 10, 11, 12, 13, 14, and it's going to keep going all the way to 26. So that's a total of 19 spaces between 8 and 27. So now we need to count over how far 14 is. Well, that would be 1, 2, 3, 4, 5, 6, 7. So it's 7 out of 19. So we're going to divide 7 divided by 19. and we get, and it's kind of a long decimal, 0.3684210, and it keeps going, but I'm just going to stop it there. We just want to round to the nearest tenth because that's what we're estimating to. So the 6 makes the 3 go up 1, and it becomes 0.4. So our estimate would be the cube root of 14 would be 2.4. We can check that by cubing the number. We're going to cube the number this time because it's a cube root. So 2.4 cubed is 13.824, which is pretty close to 14. Now let's check. We got to check all of our answers here. 2.3 cubed is 12.167. So that's a little farther away. 2.4 is still the closest. If we do 2.5 cubed, we get 15.625. And that's quite a bit of ways. So definitely 2.4 is the closest that we can get with our estimate. Do these practice problems on the left-hand side of your notebook. Make sure you show all of your work.